that we're going to give you. We're going to sometimes have data that's there but not quite apparent. So we said that 427 Papillion La Vista High students had taken the test. If 320 were proficient, how many were not proficient? 110? 107, thank you. Okay. And of the Papillion South High students, how many were not proficient? Good, because there were 413 who took it. And how many were not? 106. All right. So the numbers in this table are called joint frequencies. Okay? Joint frequencies. There's a spot for on your notes for that. These are called frequency counts. We're counting up how often these things occur. And joint frequencies just means that they have things in common. That's how we're going to remember that. Okay? If you have a joint checking account, you have a common checking account. You and your spouse, your mom and your dad, both have access to that account. Does that make sense? So this data is related in a manner. And these are joint frequencies. Okay? So the next piece of this puzzle then is something called, and I put those numbers in there, the joint relative frequencies. So I want you to find those totals over in the right-hand column. Okay? Transfer those numbers, those who met or exceeded at Papillion La Vista High, those who met or exceeded at Papillion South, and those who were not proficient. And I want you to come up with those totals. Makes sense that we should have 413 in the Papillion South total, right? And 427 in the Papillion La Vista High total. Okay. And then sum them up vertically as well. Okay. Find out how many in both schools met or exceeded the standard test scores, and how many were not proficient in those scores. And this is for NeSA Math last year. And then total up how many took the NeSA Math test altogether. Did you get 840? That's a lot of juniors between the both buildings, right? Okay, now those numbers, and again, a lot of this is vocab. This isn't really tough math. We're just adding or subtracting, right? The vocabulary is what can get a little weird. So when we're asking for marginal frequencies, we're asking for the totals. Okay, joint frequencies are the numbers that what things have in common. The marginal frequencies are the totals. So joint frequencies are those numbers that have a common something, right? And marginal frequencies, I think of the margins as being kind of the edges of the table, and that's where we're putting our totals. Okay. So joint frequencies are numbers, are counts, right? Marginal frequencies are totals of those counts, totals of that raw data. And now we're going to talk a little bit about something called joint relative frequencies. Okay, so lots of vocab here. We just want you to know what they're asking for when we ask for these things on in your assignment. Uh-huh. Which is a good thing, right? That's what I was hoping you'd notice, okay? We had more students who took the exam, right? And more students who were proficient in the math NeSA exam last spring. Okay? Yes, yes. All right, so joint relative frequency is the ratio of the frequency not in the total column or row to the total. Okay? So joint relative frequency is the numbers that are in these middle boxes divided by the total. Those counts. So we take our 320 of the students who were proficient at Papillion La Vista High, and we divide that by 840. And you write it as a decimal. And let's go to 3 decimal places. So put 0.381 in that spot. So we're going to take the number that we have in this spot, those who met or exceeded the standards, and we're going to divide it by that total number of people that were down here. Okay, so 320 by 8 divided by 840. And what did we get again? Bless you. 0.381 when we round it to 3 decimal places, right? It was 0.38095. And that 9 makes the 0 become a 1 if we're rounding to 3 decimals. Everybody get them divided out? Do they match mine? Hopefully. Okay. So those are called the joint relative frequencies. Okay. How are they related? When we divide them out by the totals, the joint relative frequencies. Okay. So before we had a joint, the joint data. This is called the joint relative because it's related to the totals. How did it happen? What did we do when we divided it? What did we get? Okay. Now, the marginal relative frequencies is simply your sum of your joint relative frequencies in your total in your rows. Okay. So we're going to add these two numbers up, these two decimals up, and put them in the total column. Add these two decimals, put them in the total, and then vertically add the decimals and vertically add the decimals. Okay, so add those up. And the state uses this data as well. They report it to the rest of the world, and people make decisions about where to send their kids to school based on this data. So this is district level data as far as the high school is concerned, or high schools are concerned. far so good? Now, let's think about what this actually means. What is this total of 0.508 in this row mean? What would that be as a percent? 50.8%. Okay. What does that mean? 50.8% of the students were what? I'm sorry. Nope, nope, that would be down here. Okay, so this is a not proficient and proficient together in this row. Right. Okay. So 50.8% of the students tested were from our school. Okay. About even, aren't they? They're pretty darn close, okay, to half and half because we have a pretty close to balanced number of students. Okay. Now, what does this mean? The 0.746. Right. How many were proficient at both schools? So 74.6%. Okay. And 25.3% were not. Okay. Yeah. Higher or lower? What do you think? Okay. Oftentimes in the core part of the cities, it's lower. Okay. Now think about it this way. If you were buying an iPad or an iPhone and 25% of the ones that you buy don't work, don't work to the level that you want them to. They don't store your contacts correctly. They don't play music properly. They don't make phone calls correctly. Your texts don't go through. What would you think? Yeah, and that's the problem with education is we can't get to that level of factory specifications because you're not widgets that we can churn out of our business, right? But as teachers and educators, we're always concerned when we have that group of 25% of our students who aren't at that proficient level, who aren't doing the math that's required in order to be successful in some of the businesses and jobs and so forth that pay a lot, pay reasonable amounts of money for a good cost of living adjustment. Does that make sense? So we're concerned when we can't reach all of you and get your scores where they need to be. Okay. However, you're not widgets in a company, right? You're not little pieces of silicone and plastic and glass and aluminum, right? That can be molded and told to do what we want you to do. There's a lot of things that are outside of our control. Makes Okay, so now what do you think the totals of the totals are going to be or should approach or be really, really close to? Yeah, it's 0.999, right? Which is really, really close to 1. Okay, these should add up to about 1. In our case, we had some rounding, and it didn't come out to be a whole even 1, but they should come close to a 1. Okay, so far so good? Haven't lost anybody. Just finding totals, right? But we have a little bit of vocab to learn. Okay, joint frequencies, joint relative frequencies means percentages, right, as decimals. And marginal relative frequencies means totals as decimals. We're just adding up rows and columns. Okay, our book decided to give you a whole bunch of vocab, and I'm not sure if that's going to show up on the ACT or the ACT Aspire or why. Maybe that's a trend that's coming, but these are new terms to me. Okay, I've done this math. What? Right. And the stats stuff is not hard. Those classes aren't hard. If you pay attention, keep up, do your work every day, learn the vocabulary. The math itself is a lot of calculator math. It's not really abstract math like your algebra can be, but stats just requires that you pay attention to vocab and that you do your work every single night, that you don't get behind. Okay? All right. So then this is where I wanted to go with this data, because this is what I'm really interested in, is how are our particular students performing. So when you talk about conditional relative frequencies, we take this data that we have in that previous table, and then we divide those numbers by the totals. Okay? So we're going to take our Papillion Livis to high, who it said only 0.381, right? Met, was proficient, and or achieved those standards, and we're going to divide it by the 0.508, that total value. Thank you. Okay. There you go. So 0.381 divided by 0.508. Change my pen color so it stands out. Mm-hmm. And not just those as well. When I was at the hosting company that I was at, my boss said, "Hey, I need to know if we're staffing right. I need to know what percentage of calls come in and tickets come in during these hours, and do we have enough bodies in the seats at those times, or should we adjust our staffing ratios so we have more people over the noon hour, or more, when do our calls come in? When are people needing help with their hosting problems, their websites?" And so I had to run the stats on it because the manager that worked in that company was great with people, but he did not have the math sense to be able to do these kinds of things. So I ran the stats and found out he needed to have more people on staff at 7, 8, 9 o'clock at night, and more people on at lunchtime. And so he adjusted his schedule accordingly, and things ran a lot smoother. So that's the kind of stuff that business owners and managers are going to be asking as well. Okay. All right, so these are the data. This is the data that I was most interested in, right? Because when we looked back a table ago, that number didn't seem very good, did it? As far as those who were proficient. But what did this tell us? 75% of our students were proficient on the NeSA Math exam, and 25% were not. Now, what we actually look at too is we actually see where the cutoffs are. And if these students had gotten one or two more questions right, now what would our percentages be? Okay? Or if they had gotten one or two more questions wrong, where would we be? And that cutoff can be an extreme swing in where we end up. Yeah. Mm-hmm. Mm-hmm. Okay. So this gives us a school level look, whereas this was giving us a district level look. How did this particular group compare to all of the students who took the exam and so forth? And now how does this look? And so when we look at state statistics as well, we always see the NeSA results as how do we perform compared to the state. So they give us a state level, a district level, and then we look at building level as well. Does that make sense? All right. So this is called the conditional relative frequency. Okay? Conditional relative frequency. So again, data that's related, right? Okay? But it's conditional based on which school you happen to be at. Okay? So joint relative frequency was frequencies related to the total, right? And then conditional relative frequencies was the decimal divided by the decimal total wise. Okay? So just a lot of vocab. Now, I've given you frequency counts for the NeSA reading now. Okay? So I want you to do this next group of examples and see if you can do the same things that we just did, but repetition and practice makes perfect, right? So now I've given you NeSA reading results, and I've told you how many were not proficient, and our numbers have changed a little bit. Okay? NeSA reading is, I think, one of the first ones that we do, or writing. By the time we get to math, it's kind of later in the year. So those numbers change and as far as how many students we have. Some have moved into the district, moved out of the district, those types of things. So I want you to figure out what is the level of meeting or exceeding for both schools, and then transfer that data to a table to the right and find the marginal frequencies for me. I'm sorry. All right, got those? Then transfer them into that table to the right. A lot of times you're not going to have multiple tables. You're just going to continue to work with one table. But to explain things without getting you lost, I wanted to show you step by step what we were doing. You okay? All done with the transferring? Awesome. Just meaning to speed up, aren't we? All right, you found your totals, right? Now do the next table, and that's going to ask for the joint relative frequencies and then the marginal relative frequencies for NeSA reading this time. Now transfer. Now figure out what your joint relative frequencies are. If you don't remember how to do it, look up here to see what you did. Mm-hmm. It looks like it's probably correct. Yes. Okay. I don't have that. I didn't key it myself. I was working on this by candlelight the other night when my power went out. It should say reading. I messed up. Mm-hmm. It's just the totals. Yep, exactly. Just learning that vocabulary. What are they asking us for? Yep. Mm-hmm. So then you said I'm going to divide it by the total number. That's perfect. Okay, so now actually tell me what that decimal is. There's not a lot of space there. And then do it to 3 decimal places. So 0.403, because the 6 will make the 2 round up. Yep, in that place. So once you find your joint relative and your marginal relative frequencies, the last step is to take that data and to find the conditional relative frequencies. And this should say for reading, not math. I have reading on or math on your paper. All right, so what did we observe about how, let's talk about on a building level, that conditional relative frequency. How did Papillion La Vista High perform compared to math? How did we do in reading? Better or worse? Just looking at ourselves, how did we perform as far as math versus reading? Okay, what percent of our students were proficient in reading? 80, right around 80, right? Okay, 79 point, what? 78 or 70, about 78 or 79% depending on the rounding, right? And about 21% were not. So that's better than our 75 4% more were proficient in reading. Okay, how did South do? A lot better, 84%, right? And they beat us in reading, whereas we beat them in math. Okay, so a little friendly competition is good, but we want to make sure that we're providing adequate resources to both sides, making sure we have the right number of math teachers, the right number of English teachers, the right number of science teachers, and so forth to balance things out and make sure that we have things covered properly. So all of those kinds of things are used to make decisions at the district level, but they're also used to make decisions at the state level. So when they find out that a specific building or district is not doing well, they decide how to fund that district, whether they're going to add more funding to it or say, you're not doing your job, we're going to take some funding away. And those are things that we have to consider, okay? That we don't have a lot of control over other than to say, please, do your best, do well in the test. Okay, so we're ready for another example, I think, okay? Now let's talk about probability and how this stuff falls into this. So we've got a store who surveyed some people, okay? Maybe it's a Walmart, maybe it's a Target, maybe it's a department store, okay? And they've surveyed their customers of different ages. And they said, would you like to see this store expand its toy department? Okay. They gave us the joint relative frequencies here. Okay, notice that we don't have just counts, joint counts. We don't have the raw numbers. We actually have the decimals divided out. And this is what the two-way table shows us. So we're to find out, first of all, what's the probability that a randomly selected customer who responded to this survey is between the ages of 10 and 20 and would not like to see the toy department expanded. Okay, so when you think of probability, what do we do when we find probability? We look for what we're looking for divided by the total number of respondents, right? Okay, so we're checking out people between the ages of 10 and 20. So we've got this middle column who would not like to see the toy department expanded. How many would not like to see it expanded? 0.17, okay? So we're going to take that 0.17 and we're going to divide it by what? Always divided by the total, right? That makes sense? What we're looking for out of total. So we don't have a total here, right? But let's quickly do this on the calculator and see if their numbers came out nicely. 0.27 adding to 0.6 hundredths, 23 hundredths, and it should be 1, right? Because this is a joint relative frequencies, and it all came out to 1, right? So 0.17 over 1 is about 17%. And you could leave it as 0.17. Okay? They didn't tell us their sample size. They just gave us this table. They calculated that all in with their joint relative frequencies. Okay, now what's the probability that a randomly selected customer who would like to see the toy department expanded is younger than 10? Yeah, 27% of those kids would like to see the toy department expanded. The others didn't care or don't think it needs to be any bigger. Okay? And then determine whether replying yes and being younger than 10 are independent events. Okay? Replying yes. What percentage replied yes? Okay? 27% of those younger than 10 said yes, right? Okay? Okay. Do you think that's dependent or independent? Okay, so there's no interaction between those who say yes and those who say no, right? It's not like they're having a discussion, right? So that should, it makes sense that it would be independent. Okay, what else are you thinking? It's not like a card, right? Where you pull a card out and you get one answer, you know, one card, and that if that impacts the other, how many cards are left in the deck, right? How many kids were younger than 10? Or how many people were younger than 10 that responded to the survey? 36%. Does 36% match that 27%? No. So just because you're under 10 doesn't mean you say yes, okay? It's not an age thing. Some of them who are under 10 said no. So those are not dependent, they're independent of each other. Okay. All right, so next one. Comparing conditional probabilities. So we have a manager of a company, like an airline, and they're worried about lost baggage. So they check the flights every day to see how many flights had lost luggage and how many had no lost luggage. Okay. And they use a tally system. Okay. The baggage handlers reported lost luggage 10 times on flight 1 and no lost luggage 3 times. Okay, 13 people. 9 times, right? And no lost luggage 5 times. And then we had 12 and 1. So we would like you to figure out which flight does the best at not having lost luggage. Flight 2. Does everybody agree? Okay. Why? You're right. You have to back it up. Tell me why. Okay. They had the least number of luggage that was lost. I agree with that. Okay. And the most satisfied customers who didn't lose their luggage. That makes sense? Okay. So the ratio of not lost luggage to lost luggage should be the highest, basically, not lost to lost. Okay. And these guys are going to be not as good. Okay. So sometimes you can look at them, sometimes you have to back it up with actually calculating it out. Everybody good? All right, backside is your assignment today. So flip it over. There's only 5 problems. 7 problems, my fault. So 7 problems. First 2 are just completing the two-way truth tables, asking you to figure out what numbers go in those spots. And then the next 2 are to actually make a two-way truth table, and then to calculate the joint and marginal, relative frequencies, and then finally find the conditional one for number 7 for the data in number 3. Okay?